Alright, Gamer Paddy here, and today I got a power supply. It's a Benning tabletop 1300 watt at 48 volts, which means, according to the label, if you can read this, I'm not sure, it's 25 amps at 48 volts. I want to start it up. The problem with server power supplies is you can't find the pinout, and some of them need special modifications in order to start up. The first thing we can do is trying to start it up without doing anything. By this, just connect the power. It's getting loud, of course, it's power supply. And it does start up, that's good. Now we have to check if the rails are actually working. Some power supplies just start up just to provide some airflow for the rest of the components, but they don't output a voltage at this point. For this, I just this way up and turn it on and multimeter, set it to volts, and try to measure the pins if there is any voltage present. Oh, let's do that. What I did just look random. I just measured a few pins, right? Actually, on those high power supplies with so many small pins, many pins are grouped together. In this case, like 3 times 5 rows is ground, and 3 times 5 rows is plus 48 volts, and the other could be control lines, but I didn't measure any voltage on these. Let's get into continuity mode. Right, this one. Of course, the ground pin of the AC line is always connected to the chassis. Now let's see. Usually the ground line of the power supply is also connected to the chassis. On some, it doesn't. Let's see. Nothing. Nothing. Alright, there it is. Just these few pins. It's good to write down what you just figured out. In this case, I'm writing down the connector. Oh damn, that's awful. Just write down 1, 2, 3. There's the power jack. That's the power supply. 1, 2, 3. And as we measured, these 6 are grouped to either ground, which is pretty low for 25 amps, or just the chassis. So let's make it ground. Now, to further look into this, I have to take it apart. So let's do this. It's important to be very careful, since we just turned it on, and and we don't know if the capacitors on the DC side or any capacitor in there is it's got a discharge resistor. Some don't, some have. Good thing is just to not touch anything with your screwdriver that doesn't look like a screw. These screws look almost the same in length, so it doesn't matter how we put it in, it just looks different because they're countersunk and they're not. Well, it doesn't really matter. Alright, we have to take off the front panel too. There's the loud fan. Let's take the lid off if we can. Alright, Mr. Screw. It's the all famous warranty label. That's the inside. Let's take off the fan without touching anything else. In case if you wonder, that's a 12-volt fan at half an amp. Not much, but it's loud. So that's the power supply. Quite impressive for 1300 watt. I mean, it's clean, simple layout, and we even got a small spider in there, but you have to get out before a capacitor will discharge you. Get the fuck out of here. Alright, let's take out the board. These are the main caps on the rectified side. These are quite dangerous. I can't touch the heatsink because it was connected to the chassis, so it's grounded. Let's take out those screws. I don't lose any washers. I think that's all. Let's see. No, there's one missing. Don't let the PCB touch the metal casing. It got an insulating sheet in there, but that's not an insurance. First of all, let's measure the capacitors, if there's any charge left. We don't want to touch this if there's any. .5 volts. 2.5 volts. That's okay. That's a safe value. Alright. We started labeling from up there. So basically those pins are going, if this is the connector, let's see if I can draw it on camera. Those pins are going like this. So the pin on this side is on the top and the pin on this side is on the bottom of this connector. Basically the pin on the top is 1, 2, 3. Did I draw this correctly? I probably didn't. Whatever. So, as we can see, as we labeled on the other side, if I can also get this back in shot, which I can, so I just draw another one right here. Ignore that. And That's 1, 2, 3. And let's count how many pins there are. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. 16 pins, alright. 16 pins, that's starting from 1. 16. So the upper 6, 1 are connected to ground, or the casing, in this case AC ground. The next one I can't see because there is no track, but we measure them later. This one is connected to a big track. Let's measure what they are exactly to identify if it's ground or VCC. We just turn the board over and look on the other side what's there. There's a capacitor, and the ground side is facing towards the connector. Turn it over again, and we can see the ground side isn't well, it's hard to see on camera, but I can see it. The ground side isn't connected to that plane on this side. We can verify that by using the continuity test, touching one of these pins and the capacitor. It just beeps because the capacitor charges, but nothing else. If we touch the positive side of the capacitor, well, it's connected. So we know these pins are VCC. In this case, this power supply just got one line, 48 volts, and probably a control line which doesn't deliver much current. It's usually 5 or 3.3 volts. We will find that later on. So let's draw the pins. On the bottom there are 3. Then there are 6, which I can see are connected together. So I make a rough drawing. Then there are 3. Then there are 12. And I should have drawn it bigger. Let's see. These are VCC. Let's see if these are connected together. These aren't. They are. All 3 of them. So they are grouped. And what are they? We know there's a capacitor. This is the negative side. So you touch the negative side and probe those pins. Right. They are not connected to the negative side. Why is that? Because if this is connected to the chassis and not connected to the negative side, this is positive, then these are the control lines because, well, there is no big plane, and these must be the ground lines. But why are they not connected? Let's turn it over. Alright, you can see there's a relay and a fuse, a 50 amp fuse in this case. And the relay is closed. If I look on the trace, I see nothing. Except the pins we are just looking at, which in my case should be ground, are going through the fuse. The fuse goes to the relay, and if you look closer, the relay goes below the capacitor. In this case, we can measure it by flipping it over again. I will link a picture in the description later on, so you can see it better. Now, I connect this lead to this pin and this lead, if I can do that. Let's connect it to this spark gap thing, to this one, and just press the relay, if I can find it. Yep, confirmed. these are ground. Now, we've still got 12, around 18 pins, which we don't know what they are for. On a few of them, you can see there are white chips. These are opto-isolators. So I got a data sheet and a new multimeter. The other one is fine. I just want to use this one. Just poked it. It's really small and I like it. Alright. This opto-isolator chip is flipped around, so we have to flip around the data sheet too. So we've got to read it. Let's just fold it. Now, that's pin 1, that's the anode. It goes through a resistor. The resistor goes to this pin. Okay, so it was the one on the left, one above. It's this one, and I just write there O1 anode, O1A. True, a resistor, of course. And where does it also go? You see this pin? Yep, it's this pin, number 6. Number 6 is VCC. So obviously this pin is VCC. It's powering this phototransistor and it's powering this anode from the LED. Let's see where the cathode goes. The cathode is pin 2. There it is. That's pin 2. So let's mark that. O1C for cathode. Now, this may be not necessary. Let's try something out. Alright, we know that there is a relay that switches the output, but we don't know if, well, we can bridge that relay and the output works. Probably. Maybe the power supply isn't even running. To test that, we have to turn it on. It's very dangerous, since we have no safety around it, and you shouldn't really touch anything at this point. So, there's a capacitor. We confirmed it earlier in the video. It's connected to the relay, to the fuse, to the output. So this capacitor must be on the power supply side, since there is no other relay. And we measure on the capacitor if there's any voltage present, if the power supply turned on. So let's turn it on. Now it's hot. Very important not to touch anything. As you can see, the LED is red, it's on. And let's measure the capacitor. Multimeter is set to volts. Absolutely nothing. Now that we are already running, let's put it onto the negative side of the capacitor and probe those pins. We don't know which they are. Nothing, 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 nothing. Oh, 5 volts. There you go. There's a 5 volts. Let's turn it off and mark where the 5 volts was. It was around 3rd row in the middle. That's 1, 2, 3. That's here. Quite hard to draw the left hand. 5 volts. Now, before we can touch this again, we have to confirm that the capacitors are discharged. They are at 70 volts. It's DC, so it's not very safe, but it's also not as dangerous as if they were charged to 300 volts. Around 40 to 50 volts is a safe level. I wouldn't touch it anyway, but it doesn't hurt as much as capacitor charged 200 volts. Right, let's turn it around. Now that we confirmed that this pin is 5 volts, let's see on the data sheet. Those are opto-isolators. This one is facing this way, so that array around, and the other one is facing that way around. That must be the input, since the device on this connector is switching the LED on this opto-isolator, and this one is telling the processor to do whatever they want. If this is a digital transmission, we got a problem. If it's just on and off, well, jackpot, why not? Let's map those other pins. I already put a flashlight behind them, so I know these 3 rows are not connected. That saves a lot of time because my camera already overheats. Now we know that this one is ground. Well, there is no ground in this. Let's see what those pins are. This one goes through a resistor, through a wire. No idea where this goes. Let's put it right there and probe. Oh, there it is. Okay. It goes through that Zener diode. Let's probe on a chip, because on the chips we can find a data sheet for them and see if it's a pin we know, in this case ground. Yep. And on this chip, yep, I already know that this one is a Atmega 8, and this pin, I already looked it up, is ground. So this pin is ground, and that's a resistor. Let's measure the resistance of it. That's 330k. But we know that this pin is connected through a resistor to ground. Map this pin. It was this one, right close to the 5 volt pin. This one. .330k to ground. We could try to enable this LED in the opto-isolator. Maybe this works. For this I prepared some jumper cables. Let's see which pins are which. We already noted them down, so I don't have to look actually. Did I label them correctly? I probably didn't. So the cathode must go to negative. Let's confirm that. Yep. This one goes to ground. In this case, we know that this resistor is connected to ground on this pin. It's the outer pin, so it must be the lower pin on this side. Let's connect it there. Cathode to this resistor. This resistor goes to this pin. It is isolated ground. That means the anode goes through the resistor to this pin. This pin is right over here. Ground. Well, I'm talking ground. That must be 5 volts. Damn. It's late. Sorry for those many cuts. The camera overheated. Alright. Now that we know that this pin goes over a resistor to this pin and it's the cathode, it must go to a voltage. And through this capacitor we can now use this pin and just connect it to the 5 volts on the pin we measured before. Well, that looks good. Just 2 jumper wires. Let's connect it again and then we can measure if there's any voltage present. Clicked. Oh, the second relay clicked. That's good. And it's making weird noises. At least it's doing something. Let's measure the ground. Well, 53 volts. We just started up the power supply. That's good. Just disconnect it. Wait for the capacitors to discharge. It's 300 volts right now. And it's going down. Yep, the relay just clicked and it stays at 80 volts. That's good. Now we know that these two pins have to be connected together. In this case, I will link a detailed picture in the description so you can do it yourself if you have one of these. Each server power supply is different. Now this one was quite easy to start up and make usable, but some others may require some more things to do. Like these ones, I made a video on these. Someone already managed to start them up and did a detailed guide how to. Basically, you connect these two pins to ground. If focus, you fuck. Well, these two pins over a 1K resistor to ground, and it should start up. But I'm not focusing on these power supplies because they are 12 volt and only 575 watt. And these one are 48 volt, 1300 watt. These are perfect for the Ruideng DPS 5015. You know, those power supply modules with the OLED display, because they are running above 50 volt and that's perfect for them. I'm going to use this one right for this DPS module. Right, let's put it back into the enclosure and we're done. Each power supply is different. In this case, we just needed 2 jumper wires to start it up. But you may find one that's harder to start up, that may require an I2C protocol. Or you may find one that doesn't need anything to start up. I know one particular one that's quite interesting, that starts up right as you connect the power, is powerful enough for anything. I mean, they are available in 1300 watt, 3000, 6000 or even 8300 watt versions. They're all running at 42 volts, not quite as useful, and they doesn't have current limiting, they just shut down. So they are called Cisco WSCAC, and then in this case 3000W or 1500W, or that was so hard to get in, what the fuck. And you can find them very cheap on eBay or anywhere else where they sell used server parts. They are used in Cisco switches to power the devices over Power over Ethernet, and they're extremely powerful, extremely cheap, around 30, 50, 60 bucks. I would rather get the 6000 watt model. It's around 60 to 80 bucks. But the 8300 watt model goes between 200 and sometimes even 1000 bucks. That's way too much. Alright, there we are. In the beginning of the video, I turned it on and you heard the extremely loud fan. It's actually not that loud in real life than on the video, but it's still annoying. Alright, let's connect it all up. And this one, cathode, goes to ground. I drew it the wrong way around. Of course, this one goes to ground. That's probably... Okay, this one, the cathode, goes to ground, which is this one. Drawing is not correct. Well, it's correct, but it's mirrored. And this one, the anode, if I I'm not mistaken. Yep, this one goes to 5 volts. It should be this one. And now when I start it up, the fan should go at 100% to, I don't know why they do this, maybe to blow dust out, and then it should lower its speed. Or not. Actually, it's not that loud. It's around the volume of a movie projector. They are quite annoying sometimes, but it's not as loud as the beginning. And as you can see, the green LED is on. 48 volts are on the pins. They are present. Let's see if that is true. Let's see if that is true. So the lower ones are negative and the upper ones are positive. Yep, there we go. 54 volts, quite high. Doesn't matter, as long as it doesn't go over 60 volts. I'm fine with it, and it runs for quite some time afterwards. Free energy! No, I'm not. Alright, that's it. I'm Gaming Paddy. Thank you for watching, and if you like, check out my other videos, or if you want, just subscribe. Well, that's it. Bye.